Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our new series on edge effects. In this last clip, we discussed how web breaks can be caused by slitting or by the mere presence of slit edges. I know your time is precious, so let's get started. In previous shows, we covered the many ways that the edges of the web can be trouble. The first show in this series showed us how to find the economic optimum amount of trim to take, and that would be applicable to most web manufacturers and converters. In this show, we focus on slitting damage that could cause web breaks, as well as why web breaks will increase due to the mere presence of slit edges, even if the slitting were perfect. There are at least a dozen common methods to cut webs. We cover them in great detail in Module 12 of our award-winning and trademark Web201 class, so we don't need to repeat that material here. Some webs are easy to cut, and several methods may work quite well for those lucky webs. Other webs are so difficult that no method works entirely problem-free. The point I want to make here for this show is that all methods can cause edge damage to any web, even if the slitting method were perfectly chosen and perfectly executed. That is simply because slitting is a violent process, no matter how it is done. Studies have shown that perhaps 80% of all web breaks are initiated at an edge. As we just saw, one reason may be that edges are damaged. However, there is also a more fundamental reason that covers even perfectly slit edges, if there were even such a thing. From fracture mechanics, we know that if the web has flaws that are uniformly distributed about the web, some will be in the middle and others near the edges. Those near the edges will be twice as likely to start a web break than those near the center due to fracture mechanics, everything else being equal. Also, of even greater importance is the radius of the tip of the flaw. Thus, we know that merely because slitting creates edges, you will get more web breaks, even with perfect cutting. These concepts are covered in great detail in Module 36 of my award-winning Web101 class, as well as my YouTube show, Web201.70a through C, so we don't need to cover those in more detail here. Another factor that is particularly important for paper is the increase in web breaks that can be expected when the paper is drier. This graph shows just such a seasonal relationship. Also of note is that paper rolls dry from the edges inward. That means that the edges are at even greater risk of web breaks due to brittleness and local tightness. These concepts are covered in great detail in Module 36 of my award-winning Web101 class, as well as my YouTube show, Web201.70c, so we don't need to cover that in more detail here. Thank you so very much for joining me this week. This concludes for now our series on why web edges can be trouble. If you have a topic you would like to hear about, Let me know in the comment section below if you found anything interesting or useful here. Please like and share and subscribe. See you next time.